In this video, we're going to be solving trigonometric equations with multiple angles. This is section 6.3 and this is day 2. All right, we're going to be doing 5 examples. We're going to solve the multiple angle equation. And so you might be thinking, well, what's a multiple angle equation? Well, let's take a look. So in the last lesson, we just solved trigonometric equations where the coefficient on the variable was 1. But in this video with our 5 examples, we're going to be solving multiple angle equations, which means this coefficient isn't going to be 1. So how do we handle that? Well, here's our problem. We want to solve for t. What angles on the unit circle, satisfy this equation? In the last video, we isolated the trig function, and we're going to do the same thing here. So right now we have cosine of 3t. This is all attached. So let's add the 1 to the other side, and then we're going to divide by the coefficient 2. We could not divide by 3 because 3 is attached to the argument or the angle, 3t, and it falls behind the cosine function. So we could not in this problem divide out this 3 just yet. That'll come later, once we detach the trig function. So let's go ahead and add 1 to the other side. So we're going to have 2 cosine 3t equals 1. This all stays together, divide by 2. So now we have cosine 3t equals 1/2. In the last lesson, like I said, the coefficient over here was just 1. So we went right to the unit circle and we found our answers. And adjusting depending upon if we're finding all solutions or on a closed interval. Well, when you look at the directions, it says solve the multiple angle equation. It doesn't say for all solutions, and it doesn't say on a particular interval. So in context, because it doesn't say anything at all, we have to understand this to mean that we're going to solve these multiple angle equation for all solutions. So that's what it means if nothing's there. When it just says solve this equation, it implies for all solutions. So we will be adding our n pi multiples or 2n pi multiples or maybe some form of a n pi multiple. All right, so we isolated cosine of 3t. We're here. We cannot divide by 3 on both sides of the equation. So the next thing is we think about, all right, well, go to the unit circle. What angles have an x coordinate of 1/2? So that's the next thing we're going to do. In the last video, we would have just brought down the t or the x or whatever the variable was. So in this lesson, we're going to just go ahead and bring down the whole 3t. So 3t equals, and let's find the angles on the unit circle that have an x coordinate cosine of 1/2. So we should have our unit circle. The x coordinates on the unit circle occur here and then also here. So this is pi over 3 and this is 5 pi over 3. So I'm going to actually set up two problems here. I'm going to go, okay, well, one of the angles that has an x coordinate of 1/2 is pi over 3. And then I'm going to remember at pi over 3 that if I go around 2 pi, I'll be back here again. And if I go around another 2 pi, I'll be back here again. So I'm going to add 2n pi. I'm going to leave a couple of spaces here, and I'm going to put the 3t down again because not only is the x coordinate 1/2 at pi over 3, but it's also 1/2 at 5 pi over 3. So I'll put 5 pi over 3. So if I'm down here, the next time I'm going to be at this location is if I added another 2 pi, added another one, etc. So added 2n pi here. All right, well, now to come back up here, I have to solve for t. Well, what I'm going to do is, instead of dividing everything by 3, what I'm going to do is multiply by the reciprocal 1/3. So I'm going to come in here and say, well, I need to isolate t now. Now's the time to do so. So instead of dividing by 3 and making this an ugly kind of situation, I'm actually going to multiply both sides of this equation by 1/3. On the left-hand side, that accomplishes our getting t equals. Now what we have to do is distribute this 1/3 into this expression. So 1/3 times pi over 3 results in pi over 9 plus, and then 1/3 times 2n pi would just result in the fraction with 2n pi on top and 3 in the denominator. So that's half of all the solutions that we have. So let's do the same thing mathematically to this other equation. So multiply both sides by 1/3. So 1/3 times 5 pi over 3 results in 5 pi over 9 plus 2n pi over 3. So both these boxed answers would represent all solutions, and there's going to be an infinite number. All right, let's do another example. I'm going to come over here and do number 2. All right, let's isolate sine 2t. So we're going to add square root of 3, and then we'll divide by this 2, but we cannot divide by this 2 just yet. We'll take care of that, like in the previous problem, towards the end of the problem. So let's add square root of 3, divide by this 2, and the resulting equation would be sine of 2t equals square root of 3 over 2. At this point, let's take this multiple angle, 2t equals, and let's go to our unit circle and find out where the y-coordinates are square root of 3 over 2. So here's your unit circle. The y-coordinates are going to be positive square root of 3 over 2 here and here. So one of the angles is pi over 3, plus we're finding all solutions, so that means add your 2n pi here. Leave a couple of blanks. So, and then again, 2t is also equal to 2 pi over 3 plus 2n pi. We're not done until we get t by itself. So now I'm going to multiply by the reciprocal 1/2 on both sides of the equation. When you multiply 1/2 times 2n pi over 2, this 2 would divide with that 2, and so we're really just left with n pi. Okay, let's isolate t again, multiply both sides of the equation by 1/2. Multiplying here gives 2 pi over 6, which reduces to 2 pi over 3. Oh, excuse me, pi over 3. Okay, so we get pi over 3 plus, and then 1/2 times 2n pi would just result in another n pi. For example 3, we have 3 tangent x divided by 2 plus 3 equals 0. All right, so I'm going to take a look at this right here. I might rewrite that. It might help me see it better. I'm going to rewrite it by writing it as 1/2 as a coefficient with the x kind of slid off the numerator, if you will. All right, let's isolate this trig function with the 1/2 x. So I'm going to subtract a 3 to the other side and then divide by this coefficient. I'm just skipping lines so that we can see it better. This is 1/2. Make sure that x is more on top than it is on bottom. So -3 divided by 3 results in -1. Okay, I can't multiply by the reciprocal 2 to both sides until I get rid of tangent. So my next move is to take the angle, 1/2 x, set it equal to, now we have to go to the unit circle. What angle on the unit circle has a tangent ratio of -1? Well, tangent's going to be negative in quadrants 2 and 4. So y divided by x here and y divided by x here would result in a -1. So this angle is 3 pi over 4. Plus, now you have two choices here. You could go all the way around 2n pi, but then you'd have to also do another equation with a half x equals this angle down here. Or if you want to just go, well, at 3 pi over 4, if I added 1 pi, not 2 pi, I would go ahead and pick up this angle down here, not having to represent it with a different equation. So there's just two ways to handle this. So I'll just go ahead and write them out separately. So 3 pi over 4 plus 2n pi. Leave a couple of blanks here. And then the 1/2 x could also equal 7 pi over 4 plus this angle plus 2n pi. Again, like I said, you don't have to do this equation as long as you put in here plus n pi. Either way, both are correct. All right, now to finish solving each of these equations, coming back to this equation, okay, I'm dividing by 2 or multiplying by half, so let's multiply by the reciprocal 2. So multiply 2 into both sides. So since this is a half, multiply by 2, I get x equals. So make 2 a fraction maybe, put 2 over 1, multiply these two together. You'll get 6 pi over 4, which reduces to 3 pi over 2. And another way to do that would be to divide this 2 with that 4, and you'd still end up with 3 pi over 2. Plus, now this is 2 times 2n pi, so the result would be 4n pi. And likewise, multiply both sides of this equation right here by 2. So I could divide the 2 into the 4 here and get 7 pi over 2. Or you could just multiply and get 14 over 4, which reduces to 7 halves. Plus, and don't forget to multiply the 2 into the 2n pi, resulting in 4n pi. Again, like I said, if you didn't want to do both these solutions and you just wanted to do 3 pi over 4, this would have been just n pi, which means when you multiply the 2 in here, this would have been 2n pi, and that would have been the only answer that you would need to have reported. In this example, I don't have to move anything over. I already have the trig function isolated, so I can actually get right to my trig values from the unit, my angles from the unit circle. All right, so let's go ahead and bring down 4x equals, what angles on the unit circle have a tangent ratio of 1? Tangent's positive in quadrant 1 and 3, so right here and right here, when you divide y by x, you'll get positive 1. So this is similar to example 3. I have a choice. I could come up with both angles adding 2n pi, or I could use one of the two angles here and just add an n pi, and that would get all the solutions. So maybe for example 4, that'll be the method that I do. So 4x equals, I'll do pi over 4, plus, instead of 2n pi, let me just add a pi, or n pi in this case, to get down here, and then another n pi would get back up here. So I don't need to set up an equation 4x equals 5 pi over 4 plus 2n pi, because this will capture all the solutions. Okay, as a final step, multiply both sides by a fourth. Pi over 16 plus, and then n pi would be stacked on top of 4. And that would be it. And I have room here, so I think I'm going to do our final example down here. So the trig function is isolated with x over 4, so I don't have to move anything or divide by any coefficients. Let's get straight to the unit circle. So x over 4, or if you want to write it as 1/4 x equals, either way. So what angle on the unit circle has an x coordinate for cosine of 0? Well, the x-coordinate is 0 here at pi over 2 and at 3 pi over 2. So x over 4, 1/4 x, is equal to pi over 2 plus, you could add 2n pi, but because we're straight across from each other, a pi angle away, you could just do n pi and not 2n pi. For this one, I guess I'll return to how I did on 3. So pi over 2, the next time all the way around, is going to be 2n pi. But then I'm also going to have to come down here. I'm going to leave a few blanks here. 1/4 x would have to equal 3 pi over 2 plus all the way around 2n pi. Again, like I said, if you don't want this last equation, then the adjustment up here would have had to have been from pi over 2, that's straight across from it, that would have had just been n pi, and that would have been fine. But the way I wrote it, I have two equations to solve. So now looking at this equation, I need to get x by itself, so let's multiply both sides of this equation by 4. So 4 times a fourth is x equals 4 pi over 2 reduces to 2 pi, or you can just divide the 2 into the 4, getting 2 pi, plus 4 times 2n pi. 4 times 2 is 8, 8n pi. And then multiply this side by 4, and let's multiply this side of the equation by 4. So make 4 a fraction, so 2 goes into 4 2 times. 2 times 3 pi is 6 pi plus 8n pi. Okay, so your answer is a combination of these two sets of solutions right here. Otherwise, if you didn't want to go to this second equation right here, then your only answer would have been 2 pi plus, and then this just would have been n pi. This would have been 4n pi right here. Either way, they're both correct. Some would say we should condense this to just one solution, but they're both correct, so that's fine. Okay, so that's solving trig equations with multiple angles.